Have you ever wondered why it's easier to walk on a flat road than to hike up a steep mountain? The difference in effort is something we all notice, but have you ever stopped to think about why that is? Or why a ball rolls faster down a steeper incline? It's a simple observation, yet it reveals a lot about the forces at play. The answer lies in a fundamental concept in physics: slope. This concept helps us understand the mechanics behind these everyday phenomena. In this essay, we will embark on a journey to understand what slope means and how it plays a crucial role in explaining the world around us. From natural landscapes to man-made structures, slope is a key element. Slope is a measure of how steep something is. It quantifies the angle or gradient of a surface. It tells us how much one quantity changes compared to another. This relationship is vital in various fields, from engineering to economics. Whether it's the incline of a hill, the steepness of a roof, or the rate at which something is changing over time, slope is everywhere. Understanding slope helps us navigate and interpret the world more effectively. In simple terms, slope is the ratio of the vertical change to the horizontal change between 2 points. Imagine you are walking up a hill. The vertical change is the difference in height from where you started to where you ended up. The horizontal change is the distance you covered horizontally. To calculate the slope, you simply divide the vertical change, also called rise, by the horizontal change, also called run. For example, if you climb 10 meters vertically for every 100 meters you walk horizontally, the slope would be 10 over 100, or 0.1. Think of a hill as a visual representation of slope. A steeper hill has a larger slope, while a gentler hill has a smaller slope. The steeper the hill, the more effort it takes to climb it. This is because you are covering more vertical distance for the same amount of horizontal distance. The concept of slope is not limited to physical hills. We can use it to describe the steepness of anything that has a slant, such as a roof, a ramp, or even a graph. Section 4. Speed and steepness. How slope affects motion. Slope plays a crucial role in determining how objects move. The angle of the slope can significantly impact the speed and acceleration of an object. Imagine you are rolling a ball down a hill. The initial position and the steepness of the hill will dictate how fast the ball will travel. The steeper the hill, the faster the ball will roll down. This is due to the increased gravitational force component acting along the slope. This is because gravity pulls the ball downwards with a constant force, and a steeper slope allows gravity to have a greater component of force acting parallel to the slope, accelerating the ball more quickly. The angle of the slope directly influences this force component. Similarly, if you are skiing down a mountain, you will go faster on a steeper slope. The same principles of physics apply to skiing as they do to rolling objects. This is why ski slopes are color-coded according to their steepness, to help skiers choose trails that match their skill level and desired speed. With black diamond slopes being the steepest, designed for expert skiers who can handle high speeds and sharp turns, and green circle slopes being the gentlest, ideal for beginners who are still learning to control their speed and movements. Section 5. Beyond the basics. Slope in graphs and equations. In this section, we will delve deeper into the concept of slope and its significance in both graphs and equations. In physics, we often use graphs to represent the relationship between different quantities. These visual representations help us understand complex data more intuitively. Slope is a key concept in understanding these graphs. It indicates the rate at which one variable changes in relation to another. For example, if we plot the distance traveled by a car over time, the slope of the line on the graph represents the car's speed. A steeper slope indicates a faster speed. Slope is also used in equations that describe physical phenomena. These equations often include terms that represent the slope, providing insights into the behavior of the system. For example, the equation for the force of gravity between two objects includes a term for the distance between them. This term is crucial for calculating the gravitational force accurately. The slope of the line on a graph of this equation tells us how the force of gravity changes as the distance between the objects changes. Understanding this relationship is essential for predicting gravitational interactions. Section 6. Keep exploring. Dive deeper into the world of physics. Slope is just one of the many fascinating concepts that physics has to offer. By understanding slope, we can better understand the world around us, from the motion of objects to the forces that govern the universe. To learn more about slope and other exciting physics concepts, check out the resources available on Khan Academy and Physics Classroom. Happy exploring!